In this slide, we are going to talk about properties of complex numbers. We'll examine the commutative law, associative law, and distributive law. We'll not prove this. To prove this, what you do is that you write z1 and z2 in the rectangular form and perform these operations, and then you'll realize that the answers comes out to be the same on the left hand side or the right hand side, whether you do z1 plus z2 or z2 plus z1. So commutative law holds for complex numbers for addition as well as multiplication, whether you put z1 multiplied by z2 or z2 multiplied by z1, it is the same. What about associative law? Associative law treats the bracket to do addition first, so z1 plus bracket z2 plus z3. Well, if we add z2 plus z3 first, then add to z1, does it matter? Answer is no. You can do z1 plus z2 first, and then add the final answer to z3. The answer is the same. Associative law holds for addition as well as multiplication. In multiplication, here the example is that z2 is multiplied with z3 first. This answer is then multiplied with z1. It doesn't really matter. We can do z1 multiplied by z2 first and then multiplied by z3. So the brackets does not matter for multiplications for complex numbers. Finally, for distribution, we have the bracket holding up z2 plus z3, and we have z1 multiplying this solution. Well, it doesn't really matter. We can open up the bracket, and we have z1 multiplied by z2 plus z1 multiplied by z3. So this is the distributive law. Again, we do not need to prove it. We are just going to use this law that's given to us. If you really want to prove it, basically you put the expression in rectangular form from the left hand side, and you work it out and you will compare it against brute force on the right hand side. You will see that the answers are the same, and therefore these three laws holds. We'll now go through some examples when dealing with square root of minus 1. Now remember that we have defined the square root of minus 1 as j. J equals to square root of minus 1. And what is then minus j? Well, minus j is minus 1 times j. So this is the idea. What is minus j? It is a real number multiplied by the imaginary square root of minus 1. Or you can put j and then minus 1 is the same, or you just simply put as minus j. It doesn't really matter. This is just a definition of how we treat minus j. Now, what about j squared? J squared, remember, is nothing but j times j. So j times j is equals to j squared. What is square root of minus 1 times square root of minus 1? And the answer is, of course, it is minus 1. So this is how we're going to work out j squared. What about j cubed? J cubed is nothing but j times j squared. Since we already know that j squared is minus 1, then it is nothing but j times minus 1, which is minus j. And now what about j4? j4 is j squared multiplied by j squared. So it's minus 1, which is j squared, multiplied by minus 1, which is 1. Now you can continue to work out what is j5, j6, and so on by following the process. What about division? So basically is we have 1 over j. 1 over j can be denoted as this j to the exponent of minus 1. So how do we get 1 over j is minus j? Well, we do it this way. 1 over j times j times j. So you have j, and what is j squared? J squared is minus 1. So j multiplied by minus 1 is minus j divided by plus 1 is equals to minus j. So this is how you work out that 1 over j is minus j. Okay? So this is the process. And what about 1 over j squared? Same, 1 over j squared is j to exponent of minus 2. And you realize that j squared is equals to 1 over minus 1. So 1 over minus 1 is of course minus 1. If you forget how to prove this, is nothing but 1 over minus 1 times minus 1 is minus 1 on the top and 1 below, and therefore the answer is minus 1. Okay, that's the idea. You can continue to do this for 1 over j3, 1 over j4, and so on. Let's continue. X is the real number and j is the square root of minus 1. So minus j times x is the same as minus x times j. Or we simply put minus jx. So that's the idea. And now we have square root of minus x. So you must be very careful when you are dealing with this. Square root of minus x square is basically this square root of minus x times square root of minus x. So because you have square root and you power it twice, so basically you will end up with minus x. That's the idea. To prove, we are going to do it this way. Square root of minus x is equals to square root of minus 1 times square root of x. So square root of minus x square is equals to square root of minus 1 square root of x times square root of minus 1 square root of x. Square root of minus 1 times square root of minus 1 is minus 1. Square root of x times square root of x is x. So the answer is minus x. So this is also how you can solve this by brute force. Now please be very careful when you have square root of, when you have this and then you think that you could remove the minus sign. There's a no. Remember that when we are dealing with square root of a negative value, we have to treat it like this. Okay, so square root of minus x must be treated as square root of x times square root of minus 1, which is square root of x times j. So we must always write this prior to before any manipulation. In the next slide, we'll show you some examples. These are really self-explanatory. I will not go through with them. But I think maybe the take-home message is this. We have square root of minus 9. We're going to deal with it by breaking minus 9 into 9 times minus 1. And then we can break it into two parts. So this is defined as j. And then square root of 9 should be plus and minus 3. So its square root of minus 9 is plus minus 3j. Okay, so you'll see why this is so using the Morse theorem again later on as well. So the rest of the examples are just a repeat of these simple examples. Thank you.